Okay, perfect. Okay, so let's start. Yeah, I will first of all give a brief introduction into what is Kubernetes, and also start a little bit with the core components and all of the different interfaces you may know. Afterwards, we'll head into RBAC and then into admission control, and in the end, this should take like half an hour, and in the end, we will go to some practical labs that are in the CTF style. Okay, so let's start. Okay, that is something like most of you have potentially seen before. That's like the core Kubernetes architecture. You may know that Kubernetes is divided into control plane, into worker and master nodes, and that on each node they are running different components. So, for example, on the control plane, they're running the Kubernetes API, they run the cloud, or they potentially runs a cloud controller manager. There potentially runs a etcd database. The etcd database can also be external. And there's a scheduler and the controller manager. And on the worker node, on the other side, we have the kubelet and we have the kube proxy. And that's very important for you because actually that means for us, if you think about, attacking Kubernetes, the first interaction point we normally have with Kubernetes is the Kubernetes API. So that's a component on the master node. And that's also like the point of entry that we are going to use if we talk to Kubernetes. Then we will go on with how do we access the Kubernetes cluster. You may know, or you all may know, kubeconfigs. And inside of those kubeconfigs, there are some very interesting things we can find. So, for example, we have the server here. That server is basically the URL and the port to the Kubernetes API server. Then we have the certificate of authority, and also you have a client certificate and the client key. Those is just a normal key pair, and this key pair is used to authenticating to the Kubernetes API. What's now important about this kubeconfig is that there were some malicious plugins out there that were just dumping the kubeconfig and then sending the kubeconfig to some malicious CNC server. So you need to actually make sure that those kubeconfig stay secret. Whoever controls your kubeconfig and the potential user, or has the client key, the client certificate, or also the tokens of a potential service account, is able to talk to the Kubernetes API. Okay. And now let's head into networking. So that's going to be also a short part. When we talk about Kubernetes networking, it's all about the CNI. You may know the container network interface, and I give you a brief example what networking in Kubernetes does look like. So we start with a normal service, like a Kubernetes service, and this Kubernetes service determines its endpoints using labels. So you see here that there's a Kubernetes service. It has the IP 111. And in order to route traffic to the correct backend, we use a selector, and this selector is basically just reads labels on the pods, and then if a pod has the appropriate label, for example, here it's app equals A, then the service routes the traffic to the corresponding pods. So in this example, you see, that there's a deployment. The deployment has a replica set, and that replica set created 3 pods. So that service now routes to this three pods, and there's a single pod, this one as well, and the pod with the label app B isn't included into the service. That also means that if you, as an attacker, control labeling, you can make services route to different pods, and that you can use, for example, to hijack DNS or something like that. There's a little quirk though, because Kubernetes by default doesn't use real load balancing. It's just IP tables with probabilities. So in this case, we have 4 pods, and each of the pods has a probability of 25% to receive the traffic. So for example, if I'm now an attacker and I can control labeling and I want to add this pod to the service, I only have a percentage of 20% to add to get traffic from the service, right? The other method is that I change the selector on the service. Those are the two things that I can do here potentially. And now if we dive a little bit deeper into Kubernetes networking, you'll see see that if we have two nodes, like we have here, for example, here's one Fedora pod, and here's another Fedora pod. You see that the networking is using a overlay network. So we are actually don't use any nutting inside of Kubernetes. That's also quite important because depending on the cluster implementation, it can actually be that, and for example, Google does it in GKE, that the pod IP range is just a secondary IP range and thus reachable directly without NUT from the node or from the primary physical network, and that we can also use to route traffic directly into pods and potentially bypassing any other stuff that runs in front of a pod, for example, a service or potentially also ingress. The next one, or the next short topic I want to introduce is Kubernetes storage. You all may know CSI. It's the Kubernetes storage interface, and that interface is responsible for storage. So, for example, what we see here is, what is Kubernetes storage? Is basically, we need Kubernetes storage because if a pod, for example, dies, then normally the data isn't kept inside of the pod. It's deleted and the pod restarts. Then the data isn't there anymore. So therefore, we need a CSI. For the CSI, the only thing that's quite interesting for security is basically how the encryption is handled by the CSI, because actually there is no default encryption for Kubernetes volumes. What you need to do is you actually need to install the correct CSI, or the CSI that matches your encryption requirements, in order to really encrypt to encrypt the storage that you use in your Kubernetes. So storage encryption is handled by the CSI and not by Kubernetes directly. Thus, installing a CSI driver that doesn't have encryption, then you cannot then you cannot encrypt your disk at all. So you need to have a look, or you need to look out if you want to use encryption. Make sure that the CSI driver does use or support encryption. Okay, and now let's head into like the last short topic for Kubernetes introduction, or the last interface, which is the runtime plugin, or CRI. And the CRI is basically quite interesting because that one is responsible for running containers. So for example, it ensures that the software runs across different environments, and also the container runtime is basically the engine behind the scenes, which makes kind of the magic of the containers possible. What's the purpose of the runtime? Like, the runtime is responsible for image pull. The runtime is responsible for the isolation. So, for example, if we spawn two pods, then those two pods cannot, access the processes of each other. The runtime is responsible for resource allocation, like CPU, memory, etc., and also lifecycle management. So, like, handles container creation, start, stop, destruction. So the runtime is like, the really workhorse behind Kubernetes. And there are several runtimes that you can potentially use. Like, the most popular one is potentially Containerd. Then there's Cryo, or there are also some special one. For example, confidential containers. You may know it. It's basically a container runtime that starts containers inside little micro VMs, and those micro VMs are then encrypted using confidential computing and features from Intel or AMD, like AMD SEV or Intel SGX, so that the RAM is encrypted. So there are special runtimes out there that can fit a specific job. Okay, and that's it for the short introduction. We will now head into role-based access. So I want to keep like the theory part a little bit short and want to do the practical part with you. Okay, so now let's head into like role-based access. So I think most of you may know role-based access. It's basically means, or role-based access in Kubernetes is the main component of regulating access to the Kubernetes API. So with RBAC, we can build the we can do like a least privilege principle. And it's so important because in Kubernetes default, there's in every pod, there's a service account token mounted. You can find it under var run secrets, Kubernetes IO service account token. And for example, if an attacker has access to a pod or somehow gets code execution side of the pod, the attacker can then use that token in order to talk to the Kubernetes API. And for us as an cluster operator, it does look like valid authentication because the token is valid, right? But in reality, it can be an attacker doing something with the token. By default, though, these service accounts don't have any permissions, so you don't need to worry about creating a service account without any role or role binding. Um, the service account won't have any permission, so it's just that the attacker has valid credentials. Okay, and then there are some standard reasons why you should use RBAC, for example, compliance and also like security. Okay, yeah, as I said, by default, new service account has no privileges. The only privileges has is the right to create a self-subject access review. That is something that you can use, for example, to look up the permissions that you have for a specific account. And also the service account token is default in every pod, but you can disable it using the Automount service account token and set it to false. And I would hardly recommend it to you that if your application does not use or does not need to talk to the Kubernetes API, then you should just opt out from using service account tokens inside of your pod, because I mean there's no need to do so. Okay. Yeah, oops. And you can deactivate that one on pod or per service account. So you can set the Automount service account token on a pod level, or you can also set it on a service account level. And there's also best practice I want to show you on the Kubernetes IO side that I've co-authored. You find here role-based access good practices, and these good practices basically represent what you should do in a cluster. I mean, we won't go through that one because we don't have the time, but you should definitely have a look at it. Oh wait, I can also share the slides. Give me a second. One second. There you go. Yeah. Okay. Yeah. Then we have some nice to know things about RBAC. So that is basically what you need to set for the API server configuration in order to use role-based access. So you can, if you want to, you can actually deactivate role-based access in Kubernetes. For example, you need to, or what you need to do to activate it is for the authorizers, you need to set the type to RBAC. Otherwise, RBAC won't be used in Kubernetes. And RBAC also has a very, let's say, interesting concept, and that's something that I often see that customers potentially do wrong. It's the concept between cluster versus namespace scope. So a role, or like the way you define RBAC is basically you can set it cluster scoped or you can set it namespaced. So basically a role in RBAC can be scoped to a specific namespace that I, for example, only have the right to get or to read pods inside a specific namespace, or I can have that right cluster-wide. And for example, if you give a service account or some user the permission to read secrets, yeah, then that's potentially bad if that permission is cluster-wide, right? And you normally only want to set it like for a specific namespace. So that's a very common misconfiguration you might see. Yeah, and also there are some permissions that needs to be defined on a cluster scope. So for example, namespaces. Yeah, namespaces cannot be scoped in namespace. I mean that's kind of logical. So you need to figure that one out, how you will design your RBAC. So we'll shortly wait for the applause. Okay. So here you see a standard role. For example, that role is just like a pod reader in the default namespace. Then I've brought to you a cluster role. That's a secret reader that can read cluster secret wide. So that's if I grant a service account or a user that role, then the user can read secrets in the whole cluster, so in every namespace basically. Then we have a role binding. So I need to create a role and afterwards, assign the role to a specific account. And in that case, I have like a human account here with the name Jane. And that account now gets granted the role pod reader, as you see here, right? And that's what this binding does. It binds a role to an account. And I can also do that one. I can also bind, for example, cluster roles to a user. So here you see a role binding for a specific user, and I'm binding a cluster role to the user. But I can also do, for example, do a cluster role binding and bind a cluster role. For example, here we bind it to a group, to the manager group. So there are like specific variations that you can do in your role-based access and you need to make sure that if you use the native Kubernetes role-based access, that you do it right. There are some alternatives out there. So, for example, if you use a managed cluster, for example, in Azure or in Google, you may use the permissions that the cloud vendor gives you or provides you. But also there, you need to make sure that your role-based access is configured correctly. If we have a look at the roles, there are some default roles built inside of every Kubernetes, and those are like the standard ones. So you have the default roles, which are cluster admin, edit, and view. The view role specifically can view everything except for secrets. The editor role can edit everything. The admin role, can is an admin for basically every resource. And the cluster admin is then a little bit further up because that one also has permissions for all of the CRDs and everything. And then there are some core component roles. For example, they are normally prefixed with a system. So you can see that if there's a system component that has a specific role, that role is prefixed with system, as you can see here. And that's also important for you because what I always see is like customers run, for example, auditing or some role-based access monitoring on their Kubernetes clusters, and then they find something like, some system component, for example, for example, some kubelet, they can exec or they can create pods that's probably too privileged for them. But I mean, it's a system component. So when you audit Kubernetes, you should have a look for those system components and potentially, let the system components or keep out of your audit. Okay. Perfect. That's for the short introduction to role-based access. And now we are heading into the last theoretical section, which is admission control. I will also share the slides here. Okay, perfect. Okay, so what is an admission controller? I think some of you have potentially heard it already. An admission controller is basically it's a resource in Kubernetes that acts kind of like a bouncer to the Kubernetes API. You can a little bit think of it. It intercepts requests to the Kubernetes API server after the authentication authorization chain, and then you can, for example, mutate or validate those requests to the Kubernetes API server. And the purpose of that component is you can block insecure, incompliant Kubernetes objects, but you can also, for example, block specific accounts from execing into pods or from doing specific actions. The why basically is, for example, what we can do with it, we can enforce the usage of network policies. So for example, what we can do is I can write an admission controller that if a namespace is created, automatically deploys inside of that namespace a default deny anything role, a default deny network policy that denies all traffic inside of that namespace. We can also, for example, use it to enforce the security context. So, for example, if you want that all of your pods are read-only, then you can have an admission controller that validates whether or not read-only root file system is set. And the same goes, for example, for Istio service mesh injection. And we have other reasons like compliance and security. We can always argue with that one. Okay, there are two, let's say, big there are two big categories for admission controllers. One is mutating, the other one is validating. So those are the two you will see or that Kubernetes also supports. And the mutating one can modify requests to the Kubernetes API server. So that is that admission controller type basically can look at an object and then change anything inside of that object. So for example, I can change the name, I can change the image, I can do whatever I want. And then it sends it, to the next stage, to the validating admission controller. Okay, so for example, as I said, I can change anything inside of the manifests. And then the example would be I can add, for example, a sidecar of a service mesh. So if I deploy pod, and then I can automatically add a sidecar using a mutating admission controller. Okay. And the other admission type we have is validating. And the validating admission controller validates API requests and can reject them potentially. So the purpose of that admission controller is to enforce compliance and ensure that, for example, certain criteria inside of Kubernetes are met. So think about either like compliance-wise. I talked about specific roles before, right? So for example, we don't want the cluster admin to be assigned to a specific service account. Then we can build a validated admission controller to validate whether or not the cluster admin role is used. Okay, and how does it work? So normally I'm as a user, I'm sending an API request, then it runs through authentication authorization, and then it's in the etcd. Like that's what most people think, but actually like the whole chain does look like this. So the user sends an API request, then it's passed by the API HTTP handler, then we're running through authentication authorization. Afterwards, it's passed into mutating admission controllers. They call their logic using a webhook. Then we run into object schema validation, and we do that because we need to check whether or not the mutating admission controller did mutate something that's still a correct Kubernetes object. Then we run into the validating admission controller, which also calls its logic using webhook. And after we pass the validating admission controller, after that one, the object is then stored in etcd. So, and that happens every time you like create or delete an object in Kubernetes. Since Kubernetes version 128, I think it is, we have something called pod security admission and standards. So let me start with standards. Standards are basically 3 levels. So that's a built-in admission controller we have. There's privileged, baseline, and restricted. And privileged is like an unrestricted policy, so I can deploy anything. Baseline is basically, I have like a minimal restrictive policy to prevent no privilege escalations, and restricted is heavily restricted and follows like the best practice of pod hardening. The thing with restricted is if you enforce restricted, some of your deployments might not work anymore because it's actually restrictive. It's hard to deploy normal software that fulfills all of the requirements from a restrictive admission controller. And then we have these pod security admission, the different modes. We have 3 modes: enforce, audit, and warn. Like enforce does what it says; it enforces a policy. Audit writes something to the Kubernetes audit logs, and warn just triggers the user-faced warning. And when we combine these two, what we can actually do, for example, on a namespace level, is we can label a namespace with that label. So here you see podsecurity.kubernetes.io/enforce restricted. So what this does is it enforces, right, in the mode enforce, it enforces the restricted pod security standard, the level restricted. So now for the namespace, my restricted namespace, I enforce the restricted standard of the built-in Kubernetes admission controller. You can look up all of the concrete rules. Wait, I will give you that. You can have a look at the concrete at the rules here. So, for example, this is the baseline profile, and you see, for example, that host processes needs to be set to false, right? Or that we are not allowed to use specific host namespaces, or privileged containers are disallowed. And if I scroll down a little bit, we will also find the restricted profile, and there you see only specific volume types are allowed anymore. And you see that run as non-root is required. So there is a little bit more. It's a little bit more restrictive. Okay. And now let's head into like the newest thing that Kubernetes added. That's called admission policies, because when the pod security standards came out, there was a discussion around whether or not these policies are, let's say, flexible enough, because these policies you find here. These policies, for example, for the restricted one, if I want to change something, or if I want to allow another volume type, I cannot do that using pod security standards. It's not possible because those rules are built into Kubernetes. So I cannot change the restricted profile. So the idea was, okay, let's give the users of Kubernetes something more, fine-grained, where they can do a little bit more fine-grained control, or have a little bit of fine-grained fine-grained control over their admission policies, and or over their admission controllers, and that is where these admission colleges come into play. And they use CEL. CEL is called Common Expression Language. It's a language from Google. And it's a policy language, like, for example, Rego. So some of you might know Rego. And these validating admission policies look like this. So, for example, I have here a validating admission policy for that matches on every create and update of a deployment in the apps API group in version v1. It must fulfill this expression. So spec replica must be less or equal 5. So if I want to create, for example, 10 replicas, that's not possible here because I have that validating admission policy that kind of, disallows me from doing it. But in order to actually use such admission policy, I also need to create a validating admission policy binding that then binds this previously shown admission policy, for example, to a specific namespace. So now that policy that you see here is only used inside, you see the namespace selector here, in the namespace select in every namespace that has the label environment test. And now in every namespace that has this label environment test set, this policy or the previously shown policy is enforced because we have a validation action here of deny. This validation action can also be audited, for example. Okay, yeah, and that's how validating admission policies are used. There are also mutating admission policies that are currently, or there's currently work around it, and they will potentially show up in, I think, the next Kubernetes version. And then we can also, mutate objects to the Kubernetes API using built-in tooling from Kubernetes. And that's for now head like a little bit into the last topic, because there's also third-party tooling for admission controllers. So most of you might know, for example, Kubernetes or the Open Policy Agent. Those are tools that allow us to to use admission control and have many predefined policies. So I can use Kubernetes and the Open Policy Agent to do all of the things that I described. But they are like third-party tools and not part of the Kubernetes standards. And also performance-wise, they are a lot slower, like it's factor 10. Than the validating admission policies. So if you need speed, or if you need the performance, then you should potentially go to the validating admission policies, because there was a very interesting case by Mercedes-Benz from Germany. They had the problem that they deployed so much into their clusters, were like hundreds of deployments every minute, and they had Kubernetes, and Kubernetes was taking too long to validate these manifests that in the end they couldn't deploy anything they wanted to deploy. And then they switched over to validating admission policies, and those were like 10 times faster, and then they could deploy anything they wanted. So you should have an eye on it, like performance-wise. But so that's it, like for this theory. And I want to head into into some labs. What? Yeah, they can work together. Yeah, like they work together. Like if you have you mean third party one and the validating one? Yeah, they can work together. Yeah, that's no problem. Okay. Okay, and now I want to head together with you into some practical stuff. And for that, I need you to register at this domain. Wait, I can just put it on here. As opposed to ransomware groups end goal, which is just encrypt everything and get payday. The keyword in APT is their goal is that long-term persistence, right? They want to hang out in that environment for months, if not years. This is the site. You can register here. And you also need to join. You also need to join a team. So if you want to, for the practical part, you can team up with as many people as you want. So that's labs are CTF style. Okay, so make sure to register. You may need a register token. Give me a second. Yeah, the registration code is DEFCON all capital. Registration code. That one. Okay. And you should be able to register. Perfect. Oh wait. Yep. Oh. Yeah. Okay. I see. Yeah. Well. How can I send you these slides then? Because I posted the links to the slides inside of the chat. Do, yeah. Yeah. I think nobody sees the Zoom chat. What? Yeah, I mean, I can do it. Or you can just give me, yeah, or you can just also send me an email and then I will, let me put that one as well in here.
So this is just to give you guys a quick look at some of the persistence methods that we're going to use. I'm going to give it right back to Jen to go over the first couple. The thing that I want to highlight here, really, well, two things really. Is
Okay,
one,
let me just
pass. Living off the land, right? We're not going to be bringing in a lot of custom binaries, with the exception of the malicious bid.
Oh, wait,
that way, I guess, but it really is still a VMware supported, tool. The other thing I want to highlight is that far right column.
Okay, so those are the links. You can just, yeah.
In April of this year, MITRE attack version 17 was released, and this has become enough of a problem that MITRE decided to make an entire framework, an entire matrix, or the attack framework rather, to address ESXi specifically. This included a few new techniques as well as porting over a bunch of other ones. And so what we've done is we've kind of tried to take probably the most predominant of those techniques from that framework.
And now I will give you some of the challenges.
I won't go through this exhaustively, but just going to give you guys
so there will be like two types. So what I normally do in my trainings is you will get some there will be some practical ones. But I will also give you some questions where you can basically test yourself. They are just question and like multiple choice questions, and you can check like did you get everything. But it's like from a little bit of the extended version of that training. So and also I will give you the practical ones. Just give me a second.
Similar thing with local SH, right?
Okay, you should see that, and now the labs as well. So I prepared 5 different scenarios, and I will just show you how to connect. So if you go to challenges now, you should see something that does look like this.
So when the ESXi host is initialized, rebooted, the boot initialization power up below the kernel.
Can you confirm that you see? What? Yeah, can you refresh? Yeah, there may be more. Okay, so like everything that's not in the lab section is like multiple choice questions that you can answer for yourself if you want to. If you want to head into practical stuff, then here are 5 labs in the bottom. Those are CTF style, so they are made without much help. And I will just show you how you can connect to a lab. So you find here a connection string called NC, and then a domain, and then 888. And then, for example, if I open a terminal, and now enter the string, you will see that I need to enter a CTFD API token to verify my identity. That's just for protection. You can click here on settings and then access tokens to get your API token. You can generate a token, and you can generate as much tokens as you want to. I mean, there's no problem. The platform can handle it. And then you can enter your CTFD API token, and then you can just click 1, create a new cluster. Then we wait a little bit. Now, in the background, on demand is a cluster for you created, so you don't need to host it by yourself. It will take like 1 minute for a cluster to be created. You can also choose like any other challenge challenge there. If you are kind of new to Kubernetes, I would recommend to you that you start with the General 2, because that's a challenge where you can check whether or not you can work with kubectl and everything. And the other challenges are then more of a exploiting one. Okay. Now you see I get a kubeconfig printed, and that kubeconfig I can now use to, I can save that. And if I do now kubectl, oops. If I do now, for example, kubectl get pods. Wait. Wait, maybe the server has died. How many of you have created a lab? Let me truly check. So the user is going to log into the ACI host, be an interactive shell, right? So not like a DCUI or a DCET. Because it should have worked. Currently unavailable. Wait, why? Maybe I need to reconnect, but what you should see normally is you should now start interacting with the cluster, and normally it should work for you. Is there somebody that needs, for example, that doesn't have kubectl or something else installed locally, because I have prepared a machine where you can SSH on? Is there somebody? So please raise your hand in order that I know. Okay, then I will give you the credentials for that. I mean, I have I have enough accounts, so that's no problem. And then you can use that from here. Okay, and then try to create your clusters. Yeah. What? Yeah, in order to in order to interact with the cluster, you need kubectl. Yeah, but I mean, if you don't have, it's not a problem, because I can give you access to a server where it's installed. Okay. Yeah, for those of you who don't have kubectl installed, give me 1 second. I'll just. Same thing, just bash script, our listener ready to go. And once we write to that, the difference grouping is we'll write this, activate our listeners, and we'll pass the game packet. But instead of just executing it right there, we're going to demonstrate, we'll say, okay, somehow our session terminates, we want the user to log in. So now we're just going to simulate that the administrators come in, doing his business, and this is kind of the victim activated payload. So for those of you who don't have a profile file will get sourced, and then that just triggers our shell. Oh wait, that was the wrong. Who don't have, or who need the server, you can use the following. I have 30 accounts prepared on that machine. So now what we're going to do is, instead of associating something with something, you can exec using training, and then 1 to 30 here. Password is the same, like SSH. Training, choose user from 1 to 30. Like, we need to make sure that we have no collisions, but I guess like currently there are only 3 people, so like there shouldn't be a collision. And then the password is also training, and then one like the user you choose. Yeah, yeah, you can also do that. Yeah. Okay. Okay. And then you can choose lab for yourself. So I would recommend that if you are like a newcomer to Kubernetes, I would recommend to start with General 2, because that's one of the easier ones. And then, for example, for RBAC 1 and RBAC 2, I mean, all of the labs are quite easy because we only have like 2 hours. But choose your lab, and then you should find a flag. You can submit that flag then and get points for it. And also, if you answer the questions, you will also get points for it. And yeah. Okay, and I will just go around a little bit and have a look at what you guys are doing. Okay. In any other service that we see on ESXi or Linux. What? So without further ado, I'm going to jump into this one. Again, we got kind of similar thing. Sorry. We're also going to use a slightly different payload in this one.
So we're going to ask our service that we're going to create here to actually use OpenSSL. We're going to use OpenSSL as the communication. So instead of just using netcast,
Yeah, I can wait.
It's a little bit harder to track where this vendor we're using traffic.
Yeah, wait. No, wait. Don't do the hello one. We do this one.
We've got a new service script that we're copying into the D directory. So you see here again, it's just got our OpenSSL.
We do that one. That's better.
Command is what it's running, so it's going to use that OpenSSL.
That's an L, by the way.
Okay.
Hopefully you can still hear me.
We're also going to try and
You can still hear me? Like, do you can still hear me in the meeting?
In
the meeting, am I still hearable? Yeah, no. I think. I mean, I don't know if you can still hear. Hey, you should hear me, right? You can hear me. Okay, perfect. I will just show you a little trick that you can do whenever you, for example, get a service account or some other account inside of Kubernetes and you don't know which permissions you have. So what we do is I will just do that locally. Whoop.
Every time you restart the machine. So this is probably your most reliable method if you want true persistence on an ESXi machine post-exploit. So yeah, we're gonna create that vid. I'm actually gonna do that for our screen. We're gonna create the vid with the C2 agent. We're gonna have the vid ready to go. We're gonna then
have it here.
ESXi box. We're gonna alter that acceptance level first thing, and then we're gonna install the malicious vid, run the C2 server on the other side, and then we're gonna have arbitrary execution. So you guys will need to see that.
Hi. Why can't I?
Here's just a couple of things that you need to understand before we are actually able to execute this attack. So one is the descriptor XML for vid creation. This is where we do a couple of things like redo is actually required for the vid install, which is just we can edit that for the vid creator. The other thing over the other side, I have to give a little bit of credit to Kaushik Wathaya and also to Austin Junior Valley Cyber for helping us kind of do some good research on that. But if you dive down through the host image.py scripts within these of the ESXi.
So what you can actually do is if you have some access to Kubernetes cluster and don't know like what your current permissions are, you can do kubectl auth can I -- list what you auth. Gotta write that correct. And now we get a little table with every permission that we have. If I have some special permissions, then you will see it here in that list, and you know exactly, for example, if you're able to create a pod, if you're able to list something. That's namespaced. So if you want to look it up in a different namespace, then you need -n in order to look up your permissions in a different namespace. But that's something you should keep in mind when you for the first time sit on a Kubernetes cluster and don't know what your permissions are. Do kubectl auth in every namespace and just have a look what your permissions are, and then you can think about like further privilege escalations or something like that.
10% of the servers had enabled the feature of the Azure Kubernetes. So that means that they might have thought that these servers are private if they use like traditional scanners, but actually they were just public servers. So we see that this problem is much larger than just database servers and buckets. It can happen in other resources.
Will that be like basics and then slowly scale up, or is it just going to feel hard?
No, we have easy challenges. Yeah, there's also learning CDF that happens from today until Saturday.
And it's worth checking out for future research, and we're sure that there will be more issues like this one.
Okay, so now we have our takeaways. So we really wanted to give you sort of a framework for this misconfiguration coverage. And we go from tactical to strategic, but also from the easier actions to the more robust. So we'll start with the discovery. We'll map, you should map all the resources in your environment, and you should scan them anonymously, but also while authenticated, also from multiple CSPs, so you won't miss any types of misconfigurations like this. Then you move to the detection part, so continuously analyze your policies and ACLs, so you should be able to 6 misconfigurations in real time.
Oh, nice. You
And
did all of
finally, the
the
prevention part, so
very good
shift
one.
left least privilege by blocking misconfiguration CI/CD
Very
pipeline.
nice.
So these misconfigurations won't even deploy to production environments. That was very quick, but
Thanks for listening, and here's the QR code. We have used the QR code for our school, open source tool, and
Yeah, for the leftover attendees, you can you still hear me in the Zoom?
Another round of applause.
Ah, okay. I don't know whether or not. But I guess I can also do it in between the talks, and I can just talk a little bit louder, and we do it between the talks, then it's fine, I guess, to do the run through there.
So you were here for that. Well, we've got a little bit of walk around. Thanks so much, everyone.
Yeah, that's yeah. I think between the talks, I can talk a little bit louder, and I'll just explain the idea behind each challenge and what you're supposed to do there. I think without going into every technical detail, I think that's okay. 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 So like a short technical run through of the or non-technical run through of the challenges. So most of you started with the general 2, which was basically a flag split into parts. The first part was to get secret, and then you got the first part of the flag. The second part, there was a secret namespace, and there you could like read the logs of container, and in the logs there was the second part. And for the third part, you got to look at the custom resource definition. There was a flag custom resource definition inside of Kubernetes, and you could just do kubectl get flags, and then you got the third part of the flag. And if you combine all of the found 3 parts, then you got 1 flag and get the points. That's for the general 2. The general 1 that you see here, which says, can you capture the flag, actually is a man in the middle that you need to execute inside of Kubernetes. So you might have heard of the 4 unpatchable CVEs in Kubernetes. There are 4 CVEs in Kubernetes that will not be patched due to system design. And one is that when you can create a service in Kubernetes, there is a field called external IP that you can define for that service. And using that field, you can basically man in the middle every IP address that you define in this external IP field. So what you got to do in that challenge is you execute this man in the middle attack against the infrastructure, against the cluster. And then we had RBAC 1. RBAC 1 was or is a challenge where you get presented a pod. That pod has, if you look at it, that pod has mounted a secret or the flag, and your goal is to read the flag. If you look at your permissions, you actually see that you can only look at the logs, and that you can create and delete pods. That's everything. And get at least pods. That's everything you can do. The idea behind the challenge is that you can read secrets without actually having the permission to read a secret.
By creating a pod that prints the secret.
Exactly. You create a pod that mounts the secret from the previously or from the existing pod. That pod that you control, because you control the pod, you can write any command into that pod, right? There's a parameter in Kubernetes called command, and there you can define what this pod actually does. For example, you can print the flag into the container logs, and then just read your pod logs that you, of the pod that you created. And that's the idea of the RBAC 1 challenge. The RBAC 2 challenge, I think nobody actually tried that, but the RBAC 2 challenge is you start out in the default namespace as a user, and then inside of the dev namespace there is a pod, and you can exec into that pod, get a token. With that token, you see, okay, I can go to other namespaces, and then you jump into the staging namespace. From the staging namespace, you go into the prod namespace, basically, and then in the prod namespace, you will find the flag. So it's just a little bit of hopping around using different service accounts in Kubernetes. And then for the last one, the admission challenge. That one is a little bit more complex because it actually is yeah, what you needed to do here is you need to define a privileged pod, and then write or create your own admission rules in order to
stop it.
to stop it. Yeah, and then you need to submit you submit the material that stops the pod from creating, and then you would get the flag. I mean, from me, because I need to manually say, yeah, that's
That will
correct.
do what you're
Yeah.
yeah.
Interesting is if you're looking for a simple pod escape. Okay, wait. You can just have a look at the hint here. I will show it to you. Wait 1 second. Yeah, there are a lot of challenges in here. Yeah. So this is, for example, what a pod escape look like. I can also briefly explain it. And you see that here we are setting host PIDs to true. So inside of this pod, we see the exact same PIDs than on the host. So PID 1 on the host is PID 1 in the pod. And then for the container, we set the security context privilege true. And if we have a privileged container running, that basically means we have access to def, so to /def. So we can read, for example, any device that's on the node level. So I can read def SDA or def NVMe or something like that. But what I'm going to do here is I do an ns enter into the mount namespace of the process with the process ID 1, and I enter, as I said, into the mount namespace. And if you know Linux a little bit, you know that the process with the process ID 1 is the init process, and the mount namespace of the init process is the root file system of a Linux system.
Which means you're bashing into
Exactly, and that's like a very easy pod escape. And for example, if I do a audit, pen test, or something like that, that's the one you try first, because if that works, you know, okay, the cluster is potentially kind of broken regarding security. So that's a very simple pod escape you can do.
Cool.
That's awesome, man.
Yeah.
Really appreciate that. Thanks.
Yeah, thank you.
Thank you.
And so you said the DEF CON Kubernetes CTF?
Yes, I will add that as well. Yeah, and if you enjoyed all of these little challenges that we had here in this training, there is actually a CTF at DEF CON completely dedicated to Kubernetes challenges that I also co-authored, and you find it on scoreboard containersecurityctf.com. That's the competitive version. There's also a learning version. If you just have a look at containersecurityctf.com, you will find how to register and everything. So here you see there's a scenario 1, which is learning CTF, and scenario 2, which is competitive. And you can register if you want to. Oh, now they're getting the.
Yeah, see, they could have done that earlier.
That
That would have helped.
Yeah, that would help a lot.
Cool.
But
Appreciate that.
hope you
Thanks.
liked it, yeah. And if you want to have the slides, you can just give me an email, and then I will send it to you.
What's your email?
It's Benjamin at Koltech, right?
Yeah, correct. Benjamin at Koltermann.